We're going to use a technique of integration called integration by parts to integrate inverse sine of x squared. Well, first we'll make a substitution. We're going to let y be inverse sine of x. Applying sine to both sides, we end up with sine of y equal to sine of inverse sine of x is x. And so cosine of y dy is equal to dx. Now, go back to the integral. This time we're going to replace all the x's with y's. Inverse sine of x is y. Since we're squaring inverse sine of x, this will be y squared. And dx is cosine of y dy. Now let's use integration by parts. U will be y squared. dv will be cosine of y dy. du is 2y dy, whereas v is sine of y. Let's replace the integral using the integration by parts formula. This is equal to u times v, which is y squared times sine of y, minus the integral of v du, which is 2y times sine of y dy. The idea is for the second integral, or the integral on the right, to be easier than the integral on the left. It is easier because the power of y on the right is 1, where it is 2 on the left. So now what we have to do is apply integration by parts to the integral on the right. So we'll take 2y sine of y, the integral of that, and apply integration by parts. Let u equal to 2y. That makes du 2 dy. And the dv will be sine of y dy. V is antiderivative, which is minus cosine of y. Now this integral equals its u times its v, so that's minus 2y cosine of y, minus the integral of v du, but notice that v has a minus, so this will be plus the integral of 2 times cosine of y dy. And we can evaluate that integral because it's just the integral of cosine. This is minus 2y cosine of y plus 2 times the sine of y. Let's return to the original integral. The original integral when variable y was the integral of y squared times cosine of y dy. And we wrote that as y squared sine y minus the integral of 2y sine y. And we just evaluated this integral, so this is equal to y squared sine of y minus 2y cosine y plus 2 times sine of y. And let's distribute that. So this is equal to, in fact, let's write out the whole integral. The integral of y squared cosine of y dy is equal to y squared sine of y plus 2y cosine of y minus 2 times the sine of y. Now we have to go back to the original variable x, and recall our substitution was y equal to inverse sine of x. So that means that sine of y will be replaced by x. So everywhere we see sine of y up here, we'll replace it with x. But now there's also a cosine of y in there, so we need to figure that out. Sine of y equals x is the same as sine of y equals x over 1. We're going to draw a right triangle, and we're going to call this angle y. Sine is opposite over hypotenuse. So if opposite side is x and the hypotenuse is 1, the adjacent side by Pythagorean theorem is square root of 1 minus x squared. So now we can finish this problem. The final answer, if we move this here, Our original integral was the integral of inverse sine of x squared, and that is equal to y squared, so that's going to be inverse sine of x squared times sine of y. Sine of y is x, plus 2y, so that's 2 times inverse sine of x times cosine of y. From the triangle, cosine of y is square root of 1 minus x squared over 1, or just the square root of 1 minus x squared, and then minus 2 sine y, which is minus 2x, and then we add a constant at the end. That's the answer. Let's rewrite it a little bit neater. The original integral was the integral of inverse sine of x squared. We were just, by using integration by parts and substitution, we found the answer to be x times inverse sine of x squared plus 2 times the square root of 1 minus x squared times inverse sine of x minus 2x plus constant of integration c. For more